All right, section 5.4 notes, such question, how do you find the real number solution to polynomial by factoring? Okay, we're going to factor the polynomial completely, so the first thing you always want to look for is greatest common factor, so we're going to factor out the greatest common factor, in this case is x. When you take out an x, you're left with x squared plus 2x minus 15. Okay, now notice right now we have a term where we have a trinomial, there's no number in front of the x squared. So what we can do is make our x and find factors of negative 15 to add up to 2, which would be 5 and negative 3. So then we can rewrite it in factor form, bring down our x plus 5, x minus 3. And that's what the answer would be in factor form or factor completely. Okay. Let's go to the next question. Okay, this one, notice how there's two terms. First thing we always want to do is factor out the greatest common factor, which would be 2y cubed. When you take out 2y cubed, you're left with y squared minus 9. Now, anytime you have two terms, so far when we've done with quadratics, we only have a binomial. You're looking for, if there's two terms, difference of two squares. Remember, the difference of two squares, if you have a perfect square minus a perfect square, take the square roots and add them, take the square roots and subtract them. And then you have it completely backwards. So the square root of y squared is 9, or sorry, the square root of y squared is y. The square root of 9 is 3, so it would be y plus 3 and y minus 3. And that would be completely factored. We have to get better on difference of two squares. We have not done a good job of recognizing that it's only two terms, both perfect squares, so we take the square roots and add and subtract them. Again, that's how we get rid of that middle term. So we got to get better at that. Let's go to the next question. Okay, again, first thing you always do is look for the greatest common factor if you factor it out. In this case, it would be 4z squared. We take out 4z squared, you're left with z squared minus 4z plus 4. Okay, now you can factor this the normal way, where you just take factors of 4 that add to negative 4. But we could also, if we recognize this, when we did complete the square, remember the first term was perfect square, last term was perfect square, then and the middle term worked out, then it was perfect square trinomial. Remember the formula for that was a squared minus 2ab plus b squared can be factored into a minus b squared. If you remember when we did complete the square. So that's the way I'm going to use in this one, just to change that practice a little bit. 4z squared. The square root of z squared, which basically all you do is take square root of this one, but there's square root of z squared is z, minus the square root of 4 is 2, so z minus 2 squared. Okay. You could have also done it the other way, where you just make your box, or your x, and you find factors of 4 that add up to negative 4. Notice how you get negative 2, negative 2. That's why you get z minus 2 squared. So either way it works. Solve that way, but just want you to know you still can use perfect square trinomials. Recognize that's perfect square, and then write it in factor form. Okay, so this is new. Sum of 2 cubes and sum of difference. Sum of 2 cubes, difference of 2 cubes. There's a rule that kind of helps out with that called SOLE. That'll help you remember the signs. Okay, the first thing is same. So if it's a cubed plus b cubed, then the first sign right here will be the same. So if there's a plus right here, this first sign will be the same. If it's a minus, then that sign will be a minus. So same. Okay, the next one is opposite. Okay, and what that means is the second sign will be opposite of the first one. So notice how this one's a plus, that one's a minus, this one's a minus, that one's a plus. Okay, so that's opposite. And then the last one is always positive. Okay, and the last sign is always positive on these type of, on sum of 2 cubes, difference of 2 cubes. Now, basically the main thing you want to do on these, according to the formula, if we look at the first one, is you want to take the cube root. Once you find the cube root, if x cubed is, if you have x cubed, then the cube root of that would just be x. Okay. If you have 8, then you need to find the cube root of 8. 1 times 8 multiple, 1 times itself 3 times gets 8, 2. So once you find the cube roots. Then it's just about plugging it in the formula, okay? Instead of a plus b, you'd have x plus 2. Instead of a squared, you'd have x squared. Instead of minus ab, you'd have minus x times 2, which is 2x. And instead of b squared, you'd have 2 squared, which is 4. Okay? And then the bottom one's the same thing, except for with some minus, you just change the signs, okay? So it'd be x minus 2, then x squared plus 2x plus 4, okay? So it's a formula that you want to try and memorize and get down. Remember, same sign, opposite, always positive, and then the last sign is always positive. So let's look at these three. First thing you always want to do is find the cube roots. Cube root of x cubed is x. Cube root of 64 is 4. Okay, so then instead of a plus b, we'll have x plus 4. Okay, first thing is always the same. Then it'd be the a term squared, which in this case would be x squared. And then the opposite sign, so minus a times b, 4x. And then the last term squared, b 4 squared would be 16. And that'd be the answer on that one. Okay? Give myself some room. We'll go down here and do b. Okay, again, the first thing, well, we're at a right here. The cube root of 27, well, multiplies by itself 3 times to get 27, 3. And the cube root of x cubed is x, so a would be 3x, and b would be, cube root of 125 is 5. 5 times 5 times 5 is 125. So then, first sign is always the same, so a minus b, or 3x minus 5, okay? Then a squared, the a term is 3x, that'd be 9x squared. And then opposite, so plus. And then we do a times b, 3x times 5 is 15x. And then we do b squared, which is 5 squared, which is 25. And that would be completely factored. The thing that's trouble is, you got to remember is that a, when we do a squared, 3x squared, you can either think of as 3x times 3x, which is 9x squared. Or you can think about it as, you know, the product of powers property, if you want to think about it that way. 3x squared, you put, it'd be 3 squared x squared, which is 9x squared. Either way it works, however you want to think about it, but you got to make sure you do that. A lot of people will just write 3x squared instead of 9x squared. Common mistake, so make sure you try not to make that. All right. The last one, if you notice, they're not perfect cubes, okay? But they do have one thing you always got to look for is greatest common factor. That greatest common factor 2z squared. So if you take out a 2z squared, you're left with 8z cubed. Wow, that's a perfect cube, or a is a cube, z cubed is a cube. And 250 divided by 2 would be 125, which is a cube. Okay? What I would recommend doing is making a cube list, because a lot of people know the square list, but they make a cube list. Let's do 1 cubed, which is 1, 2 cubed is 8, 3 cubed is 27, so on and so forth. Make one of those in your notes so you can start recognizing what the cubes are, so you know when to use this. But after that, cube root of 8z cubed would be 2z, and the cube root of 125 would be 5, which you already know that. So now, let's give ourselves some room. Okay, we'd have 2z squared, which we factored out. Then we'd have, since it's minus, same sign, 2z minus 5. Then we'd have 2z squared. 2z times 2z is 4z squared. Okay, plus, remember it's always opposite the first sign, minus, so plus, always opposite or same opposite. Then we're going to do 2z times 5, which is 10z. And then we're going to do b squared, which is 5, so 5 squared is 25. And that would be our answer. So that's some attempts to 2 cubes. That's going to take some practice to get used to. And we'll talk about more in class. Maybe do some examples of that in class. Okay. Whenever there's 4 terms, you look at the back of the wall in the room. Whenever there's 4 terms, you want to think factor by grouping. Okay. So factor by grouping, we always want to group the first 2 and the last 2 and factor out the greatest common factor. Greatest common factor in the first two is x squared, so factor out x squared, you're left with x minus 3. Greatest common factor in the second two is negative 16. So you factor out negative 16, you're left with x minus 3. Okay. So from there, then we can rewrite in factor form would be x squared minus 16, x minus 3. But x squared minus 16, if you notice, is x squared is a perfect square, 16 is a perfect square, and this is minus, so it's difference of two squares. So we take the square roots and add, take the square roots and subtract. So it would be x plus 4, x minus 4, and then x minus 3. And that would be our answer. Basically, x squared minus 16 factors into that. Okay? So that was completely factored. So when you do factor out grouping, if you notice that one of the terms has a perfect square minus a perfect square, then you got to do the difference of two squares and you got to simplify it that way. So let's do the next one. Again, if there's four terms, you always want to factor by grouping. You want to see if you can factor by grouping. So group the first two, group the last two. The first one, the greatest common factor is 9t squared. And when you take out 9t squared, you're left with 3t. And 45t squared divided by 9t squared would be 5. On the second one, the only one you can factor out is negative 1. So you factor out a negative 1, and you're left with 3t plus 5. Okay, so again, we have the same thing. We can rewrite it in factor form. Rewrite it as 9t squared minus 1 and 3t plus 5. Okay, then if you notice again, and I know this one's hard to recognize, 9t squared is a perfect square. 1 is a perfect square. So you can do the difference of two squares. Square root of 9t squared is 3t. Square root of 1 is 1. So 3t plus 1, 3t minus 1, and 3t plus 5. 9t squared minus 1 breaks into two parts. Okay? So you always have to recognize those differences of two squares. That would be your answer right there. Okay? So there's rules. If there's four terms, factor by grouping. If there's two terms, you're looking for difference of two squares, difference of cubes, sum of cubes. And if there's three terms, you want to use some type of AC method, okay? Making that x somehow. And then you always got to pay attention to whether the numbers in front of the x squared term is 1 or something else, because that changes what you do. All right, factor completely. Again, there's two terms. So if we're two terms, we're looking for difference of two squares. Well, this is a perfect square. This is a perfect square. So we got to find the square. Square root of 16x to the fourth would be 4x squared. Square root of 81 would be 9. So we can take the square roots of 9, take the square roots and subtract them. Okay? Even if it's x to the fourth, which you haven't seen yet. So it would be 4x squared plus 9, 4x squared minus 9. Now, 4x squared plus 9, we cannot break down any further because it has to be the difference of two squares. But 4x squared minus 9, these are both perfect squares. So we can take the difference of two squares, rewrite this one. Okay, square root of 2x squared, or 4x squared would be 2x. Square root of 9 would be 3. So 2x plus 3 and 2x minus 3. And now this is completely factored. So, whenever you have two terms, difference of two squares, look for it, okay? Two terms, difference of two squares, or you're looking for sum of two cubes or difference of cubes. Okay? So, the next one, always look for first, greatest common factor. This one has the greatest common factor of 2p squared. So, if you take out a 2p squared, you're left with p to the 6 plus 5p 5p to the third plus 6 plus 6. Okay. So now this is a trinomial. So if it is a trinomial, we're looking for factors of c. We're going to do the AC method, or in this case, there's no number in front of the p squared. So we're looking for factors of 6 out of 5. You can make your x if you want to. Factors of 6 out of 5 pretty easy. You know, 2 times 3 is 6. 2 plus 3 is 5. But what I have to do is, since this is p to the 6, I can't just write p plus 2, p plus 3. I have to break up p6 in half. So half of p6 is p third. So I have to break it up as, first I write my 2p squared, then I write p cubed plus 2 and p cubed plus 3. Okay? That gives us everything we want. If we boil that, you know, you get p cubed times p cubed is p6, and then you have p cubed times 3 is 3p cubed, and 2 times p cubed is 2p cubed. If you add those, you get your 5p cubed, which is right here. All right. So it does work out. So whatever this number is right here, that's 6. If that was an 8, you would break it up into 4. If that was a 10, you break it up into 5. You just break that number in half, whatever that exponent is. A little bit different, but the same principles apply on that one. Now that is completely factored. You cannot factor that any further. Okay, so let's solve. First thing on these, on any time these polynomials, we just want to set equal to 0. Okay, so subtract 30x first. We want to put it in standard form, so 2x cubed plus 4x squared minus 30x equals 0. Next thing you always do is look for any greatest common factors, which in this case is 2x. Take out a 2x and you're left with x squared plus 2x minus 15 equals 0. Okay? Then you just want to factor this. Again, there's no number in front of x squared, so we can do it the easy way. Factors negative 15 that add up to 2, which would be 5 and negative 3. So we're going to break it down. 5 times negative 3 is negative 15. 5 plus negative 3 is 2. So you can write 2x equals x plus 5, x minus 3 equals 0. Okay. So now we're solving. We're going to set each of those parts equal to 0 and solve. Okay. So we're going to have 2x equals 0, x plus 5 equals 0, and x minus 3 equals 0. Okay. So when we solve each of those, we get 0 for the first one. Anything out in front, if it has an x in it, no matter what, it's going to be x equals 0 every single time. So if you just want to write that, you can. Otherwise, you can set equal to 0 and just solve it. The second one, you just subtract 5, x equals negative 5, add 3, x equals 3. So those are your 3 answers. Okay? You have 3 answers to this problem. X equals 5, x equals 0, x equals negative 5, x equals 3. Okay? Let's go to the next one. Again, always look for greatest common factor. They all have a common factor of 4x. So you take out 4x, you're left with x to the 4th minus 10x squared plus 9 equals 0. Okay? We have 3 terms. Okay? If we have 3 terms, we want to do some form of the AC method. We want to find factors of c, which is 9 in this case, that add up to negative 10. Which I'm going to assume is going to be negative 9 and negative 1. Negative 9 times negative 1 is positive 9. Negative 9 times negative 1 is, or negative 9 plus negative 1 is negative 10. So then we can rewrite that. Remember, it's x to the 4th, so we got to break that in half. Half of x to the 4th is x squared. So we're going to write it as 4x. We're going to write it as x squared minus 9, x squared minus 1 equals 0. Now we have to keep going because both of these are the difference of 2 squares. X squared is a perfect square, 9 is a perfect square, 1 is a perfect square. So we can do the difference of 2 squares on all of those. Okay, so we'd have a 4x. Square root of x squared is x, square root of 9 is 3, so it'd be x plus 3, x minus 3. Square root of x squared is x, square root of 1 is 1, so it'd be x plus 1, x minus 1 equals 0. Okay, so now that is completely factored, and it's pretty easy to find your answers. You know, you have 4x equals 0. That's just going to be x equals 0. What's going to make x plus 3 go to 0? Negative 3. What makes x minus 3 go to 0? That's 3. What makes x plus 1 go to 0? Negative 1. What makes x minus 1 go to 0? That's 1. And you have your 5 answers. Okay. So now when you need all 5 answers to get all your points. Okay, We'll do this, or we'll talk about doing this one in class, see where you guys are at. And if you want to go over any of the problems on the notes, because you're confused or I went too fast, then we can do that in class as well. Thanks.